Good day, esteemed researchers and curious minds tuning in from around the globe. Today, we delve into the fascinating intersection of large language models and visual generative models. Our focus is on LayoutGPT, a novel approach that transforms these language models into visual planners, capable of generating plausible visual arrangements in both image space and 3D indoor scenes. This research not only enhances image compositions, but also paves the way for a unified system for multimodal tasks. Stay tuned as we unravel the potential of this exciting innovation. Our research is driven by the exploration of generative model collaborations, with a particular focus on large language models, or LLMs, and visual generative models. We've built upon prior works, utilizing 4 GPT model variants: Codex, GPT 3.5, GPT 3.5 Chat, and GPT-4. These models have been used for a variety of tasks, such as translating natural language into functioning code snippets and generating text or code from human instructions. However, we've identified a problem. GPT 3.5 Chat and GPT-4 have shown to be less effective than GPT 3.5 in learning from in-context demonstrations. This challenge is particularly pronounced when the dialogue format follows a certain structure, as opposed to free-form descriptions. This is the issue we aim to address in our work. Let's delve into the key highlights of our research. Our primary innovation is LayoutGPT, a novel approach that transforms a large language model into a visual planner. This is achieved through the use of in-context learning and CSS-style prompts. The result is a model capable of generating plausible visual arrangements, not just in image space, but also in 3D indoor scenes. This breakthrough allows us to create accurate and creative layouts, opening up new possibilities in the field of image generation and scene synthesis. As we delve into the realm of generative model collaborations, our focus sharpens on the interaction between large language models, or LLMs, and visual generative models. The image you see here provides an overview of the LayoutGPT framework. This innovative approach enables LLMs to perform 2D layout planning for text-conditioned image generation and 3D layout planning for scene synthesis. This collaboration opens up new possibilities, allowing LLMs to generate plausible visual arrangements, thereby enhancing image compositions and user efficiency. It's a significant stride towards a unified system for multimodal tasks. Large language models, or LLMs, have made significant strides in reasoning skills, a domain that has proven challenging for visual generative models. However, when it comes to text-to-image models, we encounter some roadblocks. These models often struggle to generate objects with specific counts, positions, and attributes. Similarly, 3D scene synthesis models face their own set of challenges. They often find it difficult to maintain the proportions of furniture within predefined room sizes. To overcome these hurdles, we need to develop compositional skills. These skills are essential for arranging components in a coherent manner that accurately reflects object specifications and interactions. This is the problem setting we are dealing with, and it's what led us to the creation of LayoutGPT. Visual layout serves as a crucial symbolic representation, acting as a mirror to the compositions of a visual space. However, we encounter limitations with existing layout generation models. They are often confined to discrete categories and struggle with complex text conditions due to limited reasoning skills. In contrast, large language models, such as ChatGPT, have shown promise. They are being used as a centralized module in integrated systems, bringing together multiple foundational computer vision models. This approach has opened up new possibilities, but also new challenges, which we will explore in our research. Current language model-based systems have a limitation. they struggle to enhance image composition when using text-to-image models via API calls. This is where our solution, LayoutGPT, comes into play. It's a training-free approach that empowers these models to generate appealing layouts from text conditions. The result? Improved image compositions and a boost in user efficiency during image generation. But we didn't stop there. We extended LayoutGPT's capabilities to 3D indoor scene synthesis. Now it can grasp complex 3D concepts like depth, furniture sizes, and practical arrangements. This advancement underscores the potential of large language models to handle more intricate visual inputs, opening up exciting new possibilities in the field. Our research introduces LayoutGPT, a novel approach that transforms large language models into visual planners. This innovative method allows for the generation of visual arrangements in both image space and 3D indoor scenes. We've identified a problem in the current landscape. Large language models have limitations when it comes to collaborating with visual generative models. Our solution, LayoutGPT, addresses these limitations head-on. It aims to improve the faithfulness of image compositions and enhance user efficiency in image generation. In essence, LayoutGPT is a bridge that connects the capabilities of language and visual models, opening up new possibilities in the field of generative model collaborations. Our research introduces a novel approach, LayoutGPT, which leverages in-context learning to infuse visual common sense into large language models, or LLMs. This method allows LLMs to infer visual planning for new samples, without the need for any image data, making it a training-free solution. Now, let's delve into the role of CSS style prompts in our approach. These prompts guide the generation of visual arrangements, acting as a roadmap for the LLMs. They enhance the LLM's ability to imagine object locations purely from language tokens. This unique combination of in-context learning and CSS style prompts empowers LLMs to generate plausible visual arrangements, opening up new possibilities in the field of generative model collaborations. In our research, we've utilized exemplars in a unique way. For image layouts, we've used 16 exemplars for numerical reasoning and 8 for spatial reasoning. When it comes to indoor scene synthesis, we've used 8 exemplars for bedrooms and 4 for living rooms. This approach has been instrumental in achieving our results. Now let's talk about the sampling temperature. We've kept it fixed at 0.7 for all large language models. This parameter controls the randomness of predictions, striking a balance between diversity and accuracy. Importantly, we've applied no penalty to the next token prediction, allowing the models to generate freely. This combination of strategies has allowed us to create accurate and creative image layouts and 3D indoor scenes. Our research evaluates the ability of LayoutGPT to improve image compositions and its performance in indoor scene synthesis. This evaluation is based on the generation of different layouts and images using either baselines or our proposed model, LayoutGPT. The results of our research are promising. We found that LayoutGPT's performance in indoor scene synthesis is comparable to that of supervised methods. Not only does it improve user efficiency in image generation, but it also serves as an integral part of a unified system for multimodal tasks. This means that LayoutGPT can be used in a variety of applications, making it a versatile tool for both researchers and practitioners. Diving into the key results, we find that LayoutGPT shines in its ability to create plausible visual arrangements, both in image space and 3D indoor scenes. This model isn't just about generating images, it's about enhancing compositions by creating accurate layouts. When it comes to indoor scene synthesis, LayoutGPT stands toe-to-toe with supervised methods, showcasing its robust capabilities. But it doesn't stop there. LayoutGPT also boosts user efficiency in image generation, making it an indispensable component of a unified system for tackling a variety of multimodal tasks. In essence, LayoutGPT is not just a tool, but a powerful ally in the realm of image generation and layout planning. It's a testament to the potential of large language models in revolutionizing visual generative models. Our research introduces LayoutGPT, a novel approach that leverages the power of large language models, transforming them into visual planners. This innovative method enables the generation of visual arrangements in both image space and 3D indoor scenes, providing a new perspective on how we can utilize language models in visual tasks. When it comes to performance, LayoutGPT has shown promising results. It enhances image compositions by generating accurate layouts, providing a more precise visual representation based on textual input. Moreover, in the realm of indoor scene synthesis, LayoutGPT holds its own against supervised methods, achieving comparable performance. This demonstrates the potential of our approach in bridging the gap between language understanding and visual generation. In our research, we've utilized 4 variants of GPT models: Codex, GPT 3.5, GPT 3.5 Chat, and GPT-4. Each model has its strengths, but we found that GPT 3.5 Chat and GPT-4 were less effective in learning from in-context demonstrations. Now, let's talk about the evaluation of LayoutGPT. This approach is not just about generating different layouts or images. It's about improving user efficiency in image generation and serving as an essential part of a unified system for multimodal tasks. LayoutGPT can effectively improve image compositions by generating accurate layouts, and it achieves comparable performance in indoor scene synthesis compared to supervised methods. In conclusion, we've taken a new direction in generative model collaborations, turning a large language model into a visual planner. This has opened up exciting possibilities for generating plausible visual arrangements in both image space and 3D indoor scenes.